Hi everyone. In this video we're going to take a look at the reaction and mechanism for the synthesis of acetylsalicylic acid. So first, here's our reaction itself. Salicylic acid is first mixed with acetic anhydride, which is both a reagent and a solvent, and a small catalytic amount of phosphoric acid is added to this, and our reaction produces the acetylsalicylic acid and a byproduct of acetic acid. So let's take a look at this mechanism. The first step of the mechanism is actually protonation of the acetic anhydride. Now, I'm going to rewrite phosphoric acid in a little bit more of an unusual way. Because that indicates the proton of interest, the one that's actually utilized to protonate our acetic anhydride. But rather than rewrite this each time, I'm going to simplify this just to HA, recognizing though that the phosphoric acid is the actual acid utilized. So the acetic anhydride, these carbonyls here, we're going to take one of those lone pair, grab this hydrogen, dropping those electrons on to make our anion. And we're going to have this protonated acetic anhydride produced. Now the reason why we protonate this in this step is because it makes that carbon much more electrophilic for the next step. So next we're going to draw in our salicylic acid. So the salicylic acid is going to react with this protonated acetic anhydride, which has become more electrophilic. The hydroxyl oxygen here is going to attack this electrophilic carbon, pushing these electrons up to our oxygen. Now to simplify drawing this out, I'm going to draw CO2H here instead, rather than redrawing the carboxylic acid portion each time. And this portion down here has become a little bit more tricky to draw. As we have this acetic anhydride portion which was added, and now we have this protonated oxygen here. And so at this point, our base which is present, which could be the H2PO4 anion or just A- we're going to utilize here. That base is going to deprotonate this hydrogen, pushing those electrons back up. And so at this point, as we have this attached, and again, still a little bit tricky to draw this. Okay, so we have this attached. Now what we're going to do is we're actually going to utilize this oxygen here, and this is going to become protonated. So we're going to use our HA again. This is going to grab that hydrogen, redrawing again here. So now we have this oxygen protonated. And once we protonate that, that actually turns that whole portion of the molecule into a good leaving group. So this oxygen from this hydroxyl here is going to utilize two of its electrons to reform a carbonyl. And in doing so, it's going to kick out this leaving group. Okay, and that leaving group is just acetic acid. So that's going to be a really good leaving group here. So we have this protonated carbonyl here, and again, we also formed acetic acid at this point. That's a leaving group that got kicked out there. And again, now we have to actually remove that remaining proton. And so to do that, we just again use our base, our A- here. I'm going to grab this proton, pushing these electrons back to the oxygen in that carbonyl. And we have formed our final product, our acetylsalicylic acid. So that is the reaction and the mechanism for the formation of acetylsalicylic acid utilizing a phosphoric acid catalyst.